Hi, welcome back to our video series on global temperature variability. So in the last video we talked about the difference between global and local temperature, and in this video we're going to be talking about the causes of global temperature change, or the basic physics of why temperature should change in any situation. And so the fundamental thing we need to understand in order to understand temperature change is basically that temperature changes when there is an energy imbalance. And I'll talk about what the energy is that we're talking about in this sentence and where the imbalance occurs. So first, where does the imbalance occur? So if we're talking about the Earth's climate system, we can kind of think of it in two dimensions like this. We have space up here, we have the atmosphere, we have the upper layer of the ocean, the deep ocean, and then there's some land surface over here. And so the temperature of the Earth, when we're talking about global warming, is really a measure of atmospheric temperature. So if you want the temperature to go up in the atmosphere, then you would need an imbalance where more energy is coming in than leaving the atmosphere. If you wanted the temperature to go down in the atmosphere, you'd need to have an imbalance where more energy is leaving the atmosphere than is coming in. So what energy are we talking about in the climate system? Well, we may know intuitively that the sun is what actually gives the climate system its energy. So it's releasing light towards the surface of the planet, which scientists call shortwave radiation. That light is partially reflected back to space by things like clouds, and also reflected back to space by reflective things at the surface like snow. But a portion of that light reaches the surface of the planet and warms the planet up. Now the planet then also releases energy to space, and scientists often refer to this as infrared radiation or long wave radiation. So that energy is leaving the surface of the planet, and it interacts with things like clouds and greenhouse gases, which absorb that radiation and then emit it out to space and also emit it back down towards the surface of the planet. And then there's also energy moving in and out of the upper layer of the ocean and the deep ocean. So you have energy going from the upper layers of the ocean down to the deep ocean, and energy coming from the deep ocean into the upper layers of the ocean. And so if we're thinking about the energy balance concept here, let's say that we have the same amount of energy coming in from the sun as is being reflected and as is being emitted to space. So you have the same amount coming in as leaving at the top of this diagram. Then you have energy balance. The imbalance would be 0. And then at the bottom, let's say you have the same energy going into the deep ocean as is coming out. Then you have an energy balance here as well. And so temperature wouldn't change because there's no energy imbalance. But to give you an example of an energy imbalance, let's say we were to turn up the sun or make it brighter so that it's emitting more light towards the surface of the planet. So we may have an intuitive understanding that if the sun got brighter, it would get warmer. But let's think about why that actually is. The reason why is that if you increase the brightness of the sun, you have more energy coming into the atmosphere than is leaving, and that should cause the temperature to increase. So all global temperature changes occur due to an energy imbalance. So that's the first point. And now the second point of this second video is to break temperature changes down into two broad categories. So these categories of temperature change are forced temperature change and unforced temperature change. So I'm going to explain the difference between these two in terms of our diagram again. So forced temperature change means that the energy imbalance, so all temperature changes are due to an energy imbalance. So we already have that down. So the energy imbalance is imposed from outside the ocean atmosphere system in a forced temperature change. So what does that mean? So an example of that would be if humans were to increase greenhouse gases, which we are doing. That means that we're putting more of these molecules in the atmosphere that absorb this infrared radiation, which should cause less energy to escape to space and more energy to be directed back down towards the surface of the planet. And that should cause an increase in temperature. And this is considered a forced temperature change because the ocean atmosphere system didn't create this imbalance by itself. It was imposed from outside the ocean atmosphere system. So humans are outside the ocean atmosphere system, and we put the greenhouse gases in, which cause the temperature to change. Another example of that would be if you were to turn up the sun, like we said in the last slide, that would also be a forced temperature change because the ocean atmosphere system didn't create the energy imbalance. It was imposed on the ocean atmosphere system from outside. So the sun being getting brighter is also a forced temperature change. So what about the unforced case? So an unforced temperature change is an energy imbalance created within the ocean atmosphere system itself. So this is essentially like the climate changing itself. And so a good example of this would be during a La Nina event, more energy gets moved into the deep ocean than is coming back up from the deep ocean, and that actually causes temperatures to go down. And that was not imposed on the ocean atmosphere system. The system essentially did it by itself. So there's all sorts of different natural modes of variability in the climate system. They're called modes of variability, and all they are the system basically moving energy around, moving it into the deep ocean. Sometimes you can change the clouds and change your energy imbalance at the top of the atmosphere as well. But there's no reason necessarily for it happening. It kind of just emerges out of the dynamics of the system. So that would be what we refer to as an unforced temperature change. Okay, so I want to move from the physical reasons why forced and unforced temperature changes happen to thinking about them in terms of when we look at graphs of temperature change. So I'm going to borrow an analogy from another video online about global temperature and use the analogy of the man walking his dog. And so what this is a cartoon of a man and a hat, and here's a leash, and here's the dog. And so you see the footprints of the man, or the path of the man, and you see the path of the dog here. And so we're going to be thinking about this cartoon in terms of a graph of temperature, where we have basically global temperature on the y-axis and time on the x-axis. And so the man and the dog represent forced and unforced temperature change, where the path of the man, or the movement of the man, represents the forced temperature change, which remember is the energy imbalance imposed from outside the ocean atmosphere system, like increasing greenhouse gases or like the sun changing brightness. And then the unforced temperature change is the movement of the dog. So this would be an energy imbalance created within the ocean atmosphere system itself. And so the example we gave there was a La Nina burying heat in the deep ocean, causing a short-term cooling. So something important to keep in mind here is that the observed temperature, the temperature that we actually see on any given graph, is not usually broken down into forced and unforced temperature change. What we actually see is just the path of the dog. And the path of the dog is the combined movement of the man and the dog, right? Because of the leash. Because as the man continues to go up, in this case, the dog will follow that path in the long run, but the dog is doing random things in the short run. So what that tells us is that unforced temperature change dominates the short term. So over any given time, you may see the temperature go down or up really abruptly, or then back down. And over the short run, it's kind of just random, and it's dominated by the movement of the dog. But if you zoom out and you look at the whole picture, you'll see that forced temperature change really dominates the long term. So as you go from the bottom left hand side to the upper right hand side, really the path of the man is what's dominating the temperature change. And so that will be important when we look at the pause in global warming in the next video. So in the next video we'll pick it up there, and we'll use these concepts of forced and unforced temperature change to talk about the so-called pause in global warming.